Function notation. Since functions are rules that convert inputs, typically x values, into outputs, typically your y values, it makes sense that they have their own notation. Okay, and you guys may have seen function notation. So it says to indicate what the rule is, what the input is, and what the output is. So let's practice with some function notation. It says, for each of the following functions, find the outputs for their given inputs. So here's the rule. F of x equals 3x plus 7. And that is a linear, okay, function. It's a line, 3x plus 7. So if my input is 2, I want to know, I'm just going to write I for input. If my input is 2, I want to know the output that goes with that input of 2. So we'd say 3 times 2 plus 7, 6 plus 7. That output is 13. Same thing with the negative 3. So now I'm changing my input to be negative 3. So 3 times negative 3 plus 7, that's negative 9 plus 7. So my output that goes with an input of negative 3 is negative 2. So if I change the rule and I say g of x is equal to x minus 6 divided by 2, so what's the output that goes with an input of 20? So 20 minus 6 divided by 2, that's 14 divided by 2, which is 7. So if you were to think about this in terms of a point, the point would be 20 comma 7, x comma y. So g of 0, 0 minus 6 divided by 2, that's negative 6 divided by 2, which is an output of negative 3. The point that would go with that would be 0 comma negative 3. Input is 0, output is negative 3. And a third function, h of x, is equal to the square root of 2x plus 1. Oh, back here, this one is still linear. Okay, if you graphed a bunch of points, you'd still get a line. And this one is the square root function. And we will graph the square root function towards the end of the year. It's kind of cool when you look at it. Type it into your calculator, see what it looks like. You'll see. So h of 4, so that input of 4, says we're going to take 4, multiply by 2, and then add 1 to it. That would give me 8 plus 1, which is 9. The square root of 9 is 3. And then what if I had an input of 0? 2 times 0 plus 1. So that gives me 2 times 0 is 0, plus 1 is 1. Square root of 1 is just 1. Okay, so those are just evaluating functions. So it says function notation can be very, very confusing because it really looks like multiplication due to the parentheses. But there is absolutely no multiplication involved. The notation serves two purposes. One, to tell us what the rule is, and then two, to specify an output for a given input. So our function notation, our output is y equals f, okay, that indicates the rule, and then x is your input. So if you can keep in mind that f of x is the same thing as y, you're not going to have any problem with the function notation. So if I'm given this function, f of x is equal to x divided by 3 plus 7, it says do the following. And again, this one is linear, okay? Explain what the function rule does to convert the input into an output. So meaning when you put an x in, what does this function rule do? It takes the input and it divides it by 3 first, okay? Divides by 3, then adds 7 to that result. Okay? And then it says evaluate f of 6 and f of negative 9. So f of 6 is going to be 6 divided by 3 plus 7. So that's 2 plus 7, which is 9. And then f of negative 9 is negative 9 divided by 3 plus 7. So that's negative 3 plus 7, which is a positive 4. Okay? So let's keep going with this same function here. It says find the input for which f of x equals 13. So right here, they're giving us the output, and we need to find the input that goes with it. So we've got to find the x. So we're solving for x. We know what the output is. We know what the y is. So 13 equals x divided by 3 plus 7. So we've just got that linear equation. We'd subtract 7 from both sides, and we'd end up with 6 equals x divided by 3, multiply by 3 on both sides, and you would get your input is 18. Okay? Part D says g of x. Okay, so we're bringing in a new function. G of x is equal to 2 times f of x minus 1. Then what is g of 6? So there's our input. There's our x value, 6. Okay? So right here, if it's saying that g of x is 2 times f of x minus 1, we've got to find out what f of x is given that input. So we're using our function that we've been working with, and we've got to do sort of a preliminary step here first. So I'm going to do f of 6, which is, did we do that? Oh, we did do that. That f of 6 was right up here. Okay, and we got f of 6 to be 9. So I'm just going to bring that into the problem. So we don't need to do any extra calculation. So g of x says, or g of 6 says 2 times 9 minus 1. So that's 18 minus 1. So g of 6 is 17. Okay, so our output is 17. Go ahead and flip the page. It says, recall that function rules commonly come in one of 3 forms. Equations, okay, which we did in exercise 1, graphs, and tables. So the next couple examples we're going to spend on graphs and tables. So boiling water at 212 degrees Fahrenheit is left at room temperature that is 65 degrees Fahrenheit and begins to cool. Temperature readings are taken each hour and then recorded in the table. It says in this scenario, the temperature T is a function of the number of hours H. So we've got hours and we've got temperature in terms of Fahrenheit. So it says evaluate T of 2. So my input is 2 hours. What's my output, meaning what's my temperature? My temperature is 104 for that water. Well, what about after 6 hours? 6 hours is going to be a temperature of, I should put my degrees symbol there, 68 degrees Fahrenheit. And it says, for what value of H, okay, so now we're looking for the number of hours, we're looking for that input if we're given an output of 76 degrees Fahrenheit. So I scan my table, it's 76 degrees Fahrenheit, that's after 4 hours. Okay, so we're still evaluating functions, but we don't know what the rule is, but we have the table. We have a list of inputs and outputs. It says between what 2 consecutive hours, we talked about what consecutive means, 2 hours that follow each other, will T of H equal 100? Meaning we are looking for the input, okay, given an output of 100. But it says between what 2 consecutive hours is 100 degrees Fahrenheit going to happen at? So when I look at my temperature range, I have 104 there at 2 hours, and then at 3 hours I had 85 degrees Fahrenheit. So somewhere in between 2 and 3 hours, the temperature of that water is going to be 100 degrees. Okay. Explain how you arrived at that answer. Okay. 100 degrees is between 104 and 85 degrees. And I should say between 2 and 3 hours. I shouldn't leave out my units there. All right. And the last exercise is we're dealing with a graph. Okay, so y equals f of x is defined by this graph. It is known as a piecewise linear. So because it is made up of straight line segments. So piecewise linear. Linear meaning lines, piecewise meaning pieces of lines. Okay, as shown in this graph. So now we're just going to get our inputs and outputs given a graph. So if I know that my input is 1 or my x is 1, what's the y value that goes with it? 1, 2, 3, 4. I'm just reading the graph. Next one is f of negative 3. 1, 2, negative 3. 1, 2, 3, negative 4. F of 5. Again, you're just reading right from the graph. 1, 2, 3, 4, 5. And it meets the graph down at negative 2. And then at f of 0, it's at 2. So part B says, solve each of the following for all values of the input x that make them true. So we're looking for the x given the y value. So if my y value, okay, is 0, okay, what's my x value that goes with it? I see a y value there that's 0 and a y value there that's 0. So that x value is negative 1. And also, I almost jumped over to the next question. 1, 2, 3, 4. And oops, one more right there. So 4, 5, 6, 7. Okay, so 3 inputs, okay, for that one given output. And the next one says, okay, what is the input given an output of 2? Okay, so my y value is 2 there and there. So that's an x value of 0 and an x value of 1, 2, 3. Okay, 0 and 3. So the last question says, what is the largest output achieved by this function? Largest output, largest y value, okay? That's the high point right there. So that largest y value is 1, 2, 3, 4. Y equals 4. At what x value is it hit? And the x value that goes with that is x equals 1. We're all done, guys.